Okay, this lesson starts with just draw 2 things you wish to accomplish in this new semester. So if you're doing this on paper, just draw 2 things you wish to accomplish. You can either draw them or you can write them. Okay, this slide talks about the square root parent function. And the discussion that we had in the class is we just looked at, this is what the graph of the square root function looks like. You'll notice that it starts at 0. This domain is x is 0. Y is range, y is greater than 0. It starts at the point 0, 0. So that's the x-intercept and that's the y-intercept. It has 1 root. As its end behavior is concerned, notice that as x gets bigger, f of x gets bigger. So as x approaches 0, f of x approaches 0. So that's just basically what that is. It increases all the time. As long as x is a positive number, it's increasing. It never decreases, and it has no asymptotes. Okay, that's what we discussed in class here. Now this is the most important slide. Let's look at the square root function and the parts of it as it relates to transforming. Let's look at what A controls. A controls the vertical stretch or compression by a factor of the absolute value of A. In other words, like if A is a positive number, if A is a negative number, this graph reflects across the x-axis. You're going to see that. Matter of fact, I can kind of show that to you a little bit. Let's see, let me pause this a second. Like, look at this example. I want you to notice what happens with A. Okay, if A controls the stretch, the vertical stretch, when A goes negative, the graph reflects downward. See that? But when A is bigger than 1, the graph is a vertical stretch. Okay, when A is less than 1, the graph is pushed down and becomes, this is a vertical compress. All right, so that's A. Let me go ahead and make that a 1. B controls the horizontal stretch. So when B also stretches, but this is actually what's called a horizontal compress. So this is actually what's happening. The graph is being squeezed to make it look like, it looks like a vertical stretch, but it's actually a horizontal compress. Okay, and then when B goes negative, and this is what you really need to pay attention to, when B goes negative, instead of the graph flipping on the x-axis, it flips across the y-axis because everything is horizontal. So that's what B is. So I'm going to let B be 1 here. Okay. H is the horizontal shift. K is the vertical shift. That's basically all that is. Okay, so I just explained all of this. That's what I just did. Okay, next, let's go to the next slide and get to it. Okay, so here's some examples of translations. Here, y, the square root of x plus 3, it moves the graph over 3 units. Okay, so let me show you what this looks like. Function here. Okay, look what happens when we add 3 to it. Okay, that's a vertical shift. Look what happens when I subtract 2 from it on the inside. This is a horizontal. It moves the original graph here. I'm gonna make this black. So let's compare. Okay, this is a horizontal shift. There are 2 units to the right. Let's look at this graph. This is a vertical stretch by 4. See where that 4 is? It's in the position of A. Look at here. This is a reflection. All right? Reflection. See, you got a negative sign in front. Here we have notice that it's this is where we change B to 1/2. This is a horizontal stretch. I know that sounds funny. Horizontal stretch. the graph is being pulled out like this, so it's being stretched out. Yeah, I know it's kind of hard to see. And then you got a horizontal reflection. Okay, look what a negative sign is. Look at the difference between the vertical and the horizontal. So look at that. You might need to pause the video. This top one, y is equal to negative square root x, is a vertical reflection. But the green one is a horizontal reflection. Okay, just want you to see the difference in those. So that's basically an explanation of that slide there. So let's get back to where we were. Okay, back to where we were. All right. So let's look at this graph here. What is going on from the red graph to the blue graph? We move the red graph 3 units left. See what happens? Y equals to the square root of x turns into y equals the square root of x plus 3, because we move the graph 3 units left. And then look at this graph. Then if we look at the blue graph to the green graph, we stretched it by 2. Notice that they both start off in the same spot, but this graph got stretched. It didn't get shifted, it got stretched. All right, by 2. So that's what happened there. Okay. Now here's where what I want you to do on the paper here is I want you to circle which one of these graphs has a vertical compression. One is the regular graph, graph number 1. Which one of these, 2, 3, 4, 5, 6, is a vertical compression? I'm going to pause a minute. You circle one. All right. The one that you should have circled is 3. The answer to this one is 3. Let's go to the next. Look at graph number 1. Which one of these other graphs is a vertical stretch of graph number 1? The answer should have been 2. 2 is a vertical stretch. See how that 2? Look at that A. The A value is 2. That's a vertical stretch. Which function is a reflection over the x-axis? Look at 1. Which graph is reflected? 5. The answer there is 5. Okay, see that negative sign? That lets you know it's a reflection. There are 3 reflections on this page. 1, 2, 3, 4, 5, and 6. And from graph number 1, which function has a reflection and a vertical compression? Well, you know the negative sign is going to give you the reflection. So that would be one of these down here. But which one of these is a vertical compression? Number 4. It has a reflection. There's your minus sign there, and your vertical compression. Remember, if B is a number between if A is a number between 0 and 1, you're going to have a compression. And so which function has a reflection and a vertical stretch? The answer here is a reflection, so it's got to have a negative sign, but then it's also a vertical stretch because that's bigger than 1. So 6 is the answer to there. So let's look at more than one transformation. All right. Look at the blue graph. To get from the blue graph to the green graph, you have to go 3 to the left and 2 up. To go from the blue graph to the red graph, you have to go down 4 and 1 to the right. You see that? Study this until you understand what we did. Okay? Now I want you to practice on your own. So here's what I want you to do. On this page, circle all the functions that have a vertical shift. On this page, circle all the functions that have a horizontal shift. Horizontal means H. Okay? Vertical means K. All right? Then, see, I went too fast. Let me go back. Then circle all the functions. Here we go. that has a reflection over either the X or Y axis. So you got to look at A and look at B. All right. On this page, describe what transformation is going on here. What does this -2 mean? What does this +3 mean? As it relates to the graph. You can compare it with the parent and see. All right. What I want you to do on this one, I want you to draw the function that is the square root function, 3 units left with 1 unit up. Draw it on this slide. And then see if you can write and graph this function. It's reflected over the x-axis, 2 units right, 1 unit down. All right, and then give me an idea of how well you understood this lesson. Now, I'll give you probably a little extra time with this. If you can't get into this, there is a quizzes on graphing square root functions. See if you can get that done. If you're not able to get it done before tomorrow, then let me know and I will give you another one. Okay? And that's basically the lesson. It's kind of a short version of it. All right. I hope you don't mind the pauses while I was looking for stuff. But I just thought I'd just put this out for you. Okay? Have a wonderful day.